Okay, so now we are working on Rstp. Okay, Rstp is what? It's a rapid spanning tree protocol, right?
Yes.
Now, okay, so you remember we have completed STP. Okay,
Yes.
in
Yes.
STP we have completed some STP versions like that. Okay, so let's have some
Yes.
uh, advanced protocol information. Rstp is known as Rapid Spanning Tree Protocol. Okay, uh, it's a IEEE standard. IEEE standards means like
Follow.
the Rstp can be used on any
Yeah.
platform of the switch, whether it is Cisco or non-Cisco. Okay,
Okay.
so IEEE standards is 802.1W. Okay, and STP standard is 802.1D, right?
Okay.
Okay, W is Rstp and 802.1D is STP. Now Rstp has, why Rstp came? Rapid. That's why its name is rapid. So
Yes.
Rstp has a faster convergence. Okay, as compared to STP. STP was taking 30 to 50 seconds. Rstp takes only 6 seconds. 6.
Okay.
Yes. Now the root bridge, root port, designated port election criteria is same like STP.
STP.
Now port fast is required in Rstp. Okay,
Okay.
same. You remember port fast was
That's
yeah, port fast is
configure
required in your
access.
yeah. So we will see why it is required, and for our end devices. Okay, by default uplink fast and backbone fast is enabled in Rstp. Means those feature what we have used about uplink fast and backbone fast is not
Yes.
required. It was just for information because no one is using STP nowadays.
Okay.
So Rstp is open standard protocol. We already know. Now, but when Cisco wants to use Rstp, so Cisco is using Rstp as RPVST, Rapid
Okay.
Per VLAN STP Plus.
Plus.
Okay, is a Cisco
Cisco.
proprietary protocol. See, always keep in mind by default it is, you will see as a RST RPVST, means plus
Okay.
means it's a system extended ID. Remember?
Yes.
Now understand, if we were using like STP, right? In STP,
Yes.
okay, so okay, in STP uh, we were using STP as a
Common.
common
Okay.
spanning tree. Okay,
Yes.
so in common spanning tree there was a single STP instance per switch or a single STP process per switch, right? Means if I have
Yes.
10 VLAN or 100 VLAN, only single STP process will run,
Instance.
right?
Yes.
So now, but when PVST came, PVST plus, so at that time multiple STP instance was running depending on the VLANs, right? Per VLAN.
Yes.
So if I have 10 VLAN, so you will have 10
Then
STP
instance.
process, right? Or 10 BPDU
Yes.
traveling in the network, right?
Yes.
And if we are talking about CST, CST do not provide load balancing, because if you
Okay.
have only single instance, then how you can provide load balancing? Load balancing
Okay.
means what? You can have multiple instance, then you can provide, okay, one instance go from
Yes.
this link, one instance go from this
Yes.
link.
Yes.
Okay. Now, but PVST provide load balancing because of multiple instance, and we have seen this one also, right?
Yes.
Yes. Now RSTP, rapid spanning tree. Rapid spanning tree was also open standard, STP was also a open standard.
Yes.
Okay, PVST was a Cisco proprietary. Okay,
Okay.
now, so when RSTP is a open standard means single instance,
Yes.
same process, single instance, no load balancing. But when we are talking
Yes.
about Cisco rapid per VLAN STP plus, then multiple instance per VLAN. Okay,
Yes.
and it
Provide
also
load
provide
balancing.
load balancing, so it's benefit as compared to others, right?
Yes.
Okay, now BPDU messages in RSTP. Okay, so in STP only root switch was generating configuration BPDU. You remember we have there was two type of BPDU. One is configuration BPDU and topology change
One is
notification
configuration.
BPDU, right?
Application, yes.
Yes, but configuration was only generated by root switch. Means configuration means suppose I am root and you are non-root, right?
Yes.
And some other switches are connected to you.
Yes.
Okay, like okay, instead of let me if you remember about do you remember about OSPF DRBDR?
Yes.
Okay, good.
GR, GR is like the root bridge, right?
Yes, yes, yes. Okay, suppose here is one switch.
Yes.
Okay, and here is one switch, and they are connected using some link. Okay, this is our switch 1, switch 1. This is our switch 2. This is our switch 3, and this is our switch 4. So this is our root. Okay, this is our root. Now, so this is what DP.
DP.
This is our
DP.
DP. This is what
Yes.
RP.
R. Yes.
This is
RP.
RP.
Yes.
This is DP.
DP.
This is also DP.
DP.
Okay, and now
Yes.
tell me which one will be RP here.
This one.
This one,
The,
very good.
the, the,
RP,
the,
and here will be
and that one block.
block. Okay, now if any changes will come here, suppose if any changes came to your topology, so any configuration, if any configuration, so your root switch will send configuration BPDU.
Configuration change. Mhm.
BPDU will be always sent by a root or generated via root
Yes.
to all others. Okay, TCN is what? Maybe if this link is down, maybe for example after some time, okay, if this link is down, right?
Yes.
Okay, so who will know about that this link is down?
Yes. Switch 4.
Switch 2 and switch 3 will know that this link is down.
No, no.
Of course switch 4 will also know, but
Yes.
here see they are sending BPDU in every 2 seconds as a keep alive, right?
Yes.
Okay, so this link is blocked, but when this link is down, right, or maybe if this link is down, right,
Yes.
so these two switch will know about this
Yes.
information that okay, yes, switch 4 has the problem, right? Are you
Yes.
understanding?
Yes.
So this switch 2 and switch
Yes. I
3
see.
will be responsible to update this information to
Switch the root switch.
root switch, so they will generate TCN BPDU. Okay,
So all of the trois will generate this one.
all
All of the trois. All of the three. I mean.
not 3, this switch 2 and switch 3 will send that sir, there is some changes in the network.
Okay. So what about the switch 4? The switch
For
4 will not generate to them.
yeah, switch 4 generate TCN.
Okay.
TCN and informed to switch 2 and switch 3 to upstream,
Okay.
and
And then
switch
they
2
will
and switch
forward it
3 will
to.
update to switch 1. and switch 1 will
Okay. Yes.
finally send this information about the topology change. So topology change means that
Okay.
my friend, now he will say that to everyone, that my friend, uh, please, when your root port, this is okay, maybe here will be some changes, here will be some changes, the changes, what, see, if this link good has
Yes.
gone down, right? Okay,
Yes.
so and this link came up, are you understanding?
Yes.
So
Yes.
there was, the means the scenario was different earlier, but now the
Yes.
topology is different. So
Yeah.
you informed, switch 4 informed to switch 3, okay, if this link is down, so switch 4 will
Yes.
inform to switch 3. If this link will
Yes.
down, so switch 4 will update to
Switch to.
switch to TCN, then switch 3 will update this to TCN to
Okay. Root switch.
root switch. That, sirs, there are some changes in the topology, okay, and I
Yes.
received those changes, so I'm just giving to you because I cannot share with others, okay.
Yes.
Why I cannot share with others? Because this port is blocked. Understood? See,
Yes.
let me come again. Okay, maybe there could be other link also like this one. Okay, now tell me the status of this link. This will be what? DP?
DP.
Okay, and what about
The other
this
one
one?
is. This one is blocked.
Very good. Block. Okay, now
Yes.
if this link is down something, right? So I cannot, means,
Yes.
see, non-root switch cannot update any information to non-root switches. They can only update
Yes.
to
Root switch.
root switches only.
Yes.
Okay, now, so TCN can be generated by, see, if there are changes on root, so root can update, root, see, if there is any changes on root, so root will generate directly configuration BPDU. Root will not say about
Okay.
TCN, because TCN is
So
only for
the
root and I'm root and there is some changes, okay,
okay.
and
So the
changes,
TCN does not regard the root bridge.
yes, so whatever changes is there, so root switch
Yes.
has to inform to other switches. So root will inform
Yes.
about the changes through configuration BPDU, and
Okay.
non-root switch will inform about changes to root with
The TCN.
TCN. Very good. Okay. So in STP only root switch was generating configuration BPDU and non-root switches was generating TCN to root switch, and root switch was updating about the new topology to other switches by
Configuration BPU.
configuration BPDU. But in Rstp all switches generate configuration BPDU. That's why TCN BPDU is
Not required.
not required. So if everyone is generating topology change, not sorry, configuration BPDU, and
Okay.
everything is there, so what is the needs of TCN now?
Yes.
Okay, so Rstp do not use TCN. Now when we are talking about configuration BPDU field, so configuration BPDU field is protocol ID, protocol version, type, flag, means protocol ID, which protocol you are using. Okay, RSTP, STP, PVST, RSTP plus, protocol version. Okay, version means you are
Okay.
using CST, PVST, PVST plus, like that. Type. Okay,
Yeah.
okay, type means, like, I think it's a version, VPDU version is that, okay, version, no, protocol version, this is the, okay, this is, I think,
Okay.
STP or BPDU, I think, yeah, BPDU version 1 or version 2. Okay, type is
Okay.
PVST plus. Flag,
Fast. Yeah.
yes, this is flag, I will let you know later. Okay,
Okay.
now flag is related to update. Okay, okay, I will
Okay.
show you, we have flag information as well. Now root bridge ID. Okay, so root bridge ID is 32768 plus your MAC address plus
Yes.
your,
Priority and MAC address.
yes, cost is the link, whether it is 19, okay,
Yeah.
for that
19.
cost, okay, link cost. Now
19
designated
is
bridge
for
ID,
fast.
yes,
19 is for fast.
yes, 4 is for uh,
Giga.
yeah, 1 gig, and one is for 10 gig.
Yes.
Okay, now destination, see, designated bridge ID. Designated bridge ID means, remember when you run so a spanning tree, so you get your route ID and your ID, right?
Yes.
Okay, now designated port ID means if someone is connected, see, this is my designated port, right? This is my
Yes.
designated port. So designated
Yeah.
port and designated ID is different.
Yeah.
Okay, designated means, see, suppose if I added this port into VLAN 10. Okay, so
Okay.
what will be the bridge ID for this one? And if I added this link in VLAN 20, so ID will be different for him, right?
Yes.
Yes, so that's why it designated bridge ID and port ID is 128 something, that one. Okay, max age is 20 seconds, that will be in that field, BPD field, which will be shared with the neighbors. Okay, and this is disabled, not in use. Okay, because the table will be there. Okay, the
Okay.
information will be there, but it is not in use because RSTP use 6. Okay, 6 seconds, total 6 second. Okay, now forward delay timing, see, max timing is not in use because hold timer is not there in RSTP. Okay,
Yes.
forward delay timer is there, but it is not in use. Okay,
Okay.
now message age, see, max age is different and message age is different.
Okay.
Message age is 7 hop. 7 hop means, suppose this is a switch 1. Switch 1 generated one configuration BPDU, right? This configuration
Yeah.
BPDU, this one. Okay, so this configuration BPDU will travel in the network how long? So remember
Yes.
RIP has how many hops? 15 hop, right?
16 or yeah, 15.
Yeah, 16 was unreachable. So this
Yes.
root configuration BPDU hop is 7 hop. Means after 7,
Okay.
like
Yes.
one switch, two switch, three switch, four four switch, like that. So if this BPDU is coming, okay, so this BPDU will travel to switch to 1 hop, 2 hop, 3, 4, 5, 6, and one more 7. After that, this
Okay.
configuration BPDU will drop.
Okay.
Okay, it cannot reach more than 7
7.
7 switches. Now you will see that, then what about others? But my friend, if you will see here, let me open one thing. Google Cisco 3 layer hierarchy model. See, if you are talking about any large network also, right? Okay, so you will never find switches. See here, this is the root switch, right?
Yeah.
Okay, and this root switch wants to reach to this end access layer. Okay, see, 1 hop,
Yes.
2 hop. That's why they use multiple links, redundant links, right?
Okay.
Okay, so you will never find, see, if you if you want to utilize 7 hops, right, means you have to add at least 400 or 500 switches in the network.
I see.
Yes, see here, see, 1 2 3 4 5 6 7 8 9 switches is there, but if this switch wants
Yes.
to reach here, see, 1 hop, 2 hop.
I cannot.
Okay, see here,
If
if
there
you
is no.
take, yeah, if you take this example, 1 2 3 4 5 6 7 8 9 10 here, but if this switch wants to send any information to this end user, see, 1 hop, 2
Yes.
hop.
So many redundancies.
Yes, so you cannot utilize those all 7 hops. Okay, but the limitation is 7 hops. Now in STP the max age was 20 seconds, but here we have like there is no max age now. Okay, now what are you saying here? The max age was 10 hello message, right?
Times
Yeah, times 2.
yes.
Yeah. Now default root switch, if we are configuring some kind of network here, okay, so this is our switch 1, this is our switch 2. Okay, here we have, this is our DP, this is our DP, this is our fast ethernet 1, fast ethernet 2. So automatically you will see that this is your RP and this will be your block, right? Okay,
Yes.
due to the lowest port number on root
Yes.
switch, right? Now RSTP use max age 3 time
The
hello,
time.
means 6 seconds. Okay, now let's talk about something like port state in STP and port states in RSTP. Port state, remember we when we were talking about STP, it was disabled, right? Port was disabled.
Yes.
Then after disable, it was moving to listening, then it was moving to
Listening.
learning, then it was moving to forwarding. And if something was blocked due to listening, and you remember block, after blocking, listening, learning, then forwarding, right? Okay, so when it was disabled, so it was taking 15 seconds, 15 seconds, 30
Yeah.
seconds, right, to come into forwarding.
Yes.
So it was taking 30 seconds,
20. Yeah.
30 seconds, 15 here and 15 here,
Yes.
right?
Okay.
Yeah, and blocking was 20,
20 plus,
hold,
plus 30.
yeah, 15, 15, so it was taking 50 seconds.
Yeah.
But when we are talking about port states
Rapid.
in RSTP, so it is discarding.
Okay.
Okay, the first is discarding. After discarding, when it is on, it will immediately, it will go for learning,
Okay.
and after learning it will go for forwarding directly.
Okay.
Okay, now you will say that, okay, now understood that here we have 5 stages. Okay, and here we
Yes.
have 3 states. Okay,
Three.
discarding, learning and forwarding, that's it. And
How
in
many times gonna take?
6 total.
Okay.
Okay,
Not too much.
and there is some process also, I cannot say 6. Okay, immediate.
Okay.
6 second is what? Nothing. Okay,
Yes.
6 second means what? I'm not saying 6 second is total. Okay,
Yeah.
but total single is 2 seconds, you can say that 2 seconds, total is 2 seconds. Okay, see
Okay.
here, max age was 6 seconds, means hold time is 6 seconds, means if I'm not listening any BPDU from my neighbor, then I can wait for 6 seconds, after that I will enable my port, this block port, right?
Okay. Okay.
But every 2 seconds I'm getting message.
Yes.
Okay, so you can say, okay, you will see something from discarding to learning, it's faster. Wait is 6
Yes.
seconds. Now
Okay.
port state, we have seen that, okay, it is disable, blocking, listening, learning, forwarding. But here port roles, in STP is designated port. See, whatever
Yes.
process will run after that, your port can be DP, or your port can be alternate. Okay,
Okay.
or your port can be access port, right?
Access port.
Or your port can be, oh my god,
Alternate.
R DP RP, sorry, instead of RP
Okay.
I have written AP.
Okay.
Sorry. Okay, DP,
Designated.
RP, or alternate block, right? So whether your
Alternate is
port
like
will
what?
be designated root port or alternate port. But here in RSTP, your port can be DP, RP, alternate and backup.
Backup.
Yes. Okay, see here. If you'll see this scenario, designated port, root
Designated.
port,
Yes. Yes.
designated port, but there is some block backup port as well.
Okay.
Okay, and there is some alternate port as well, and there
Okay.
is some edge port also. Edge port, see, port
It's
fast is
ending.
used
It's
in STP. okay,
Yes.
and the PVST, okay.
Okay.
But when we are talking about the RSTP, in RSTP the end devices users access
Yes.
port is known as edge port. That's why remember when we were configuring something regarding port fast, so we were
Yeah,
giving
we
something
saw it.
edge, yes, because the we were using some new switches, that's why.
Yeah.
Okay, so now port roles in STP and port roles in RSTP. So in STP and RSTP, the flag fields is of 8 bit. Flag fields means the information what they are exchanging with the neighbors. Okay,
Okay.
so with the flag field, they will know that okay, what information you are sharing with me. Okay, and the information what you are sharing with me, according to the information, I will change my port roles and port status, right? Whether I will be DP,
Okay.
whether I will be RP, like that, right? Okay,
Yes.
now see, remember protocol, identifier, protocol version, BPD type, flag, these all things we talked about, but this is the main one,
Yes.
flag. In flag, what they are sending? Okay, so in flag, they send topology change. Okay, not topology change notification.
Okay.
Okay, they change means topology has changed. Okay, please
Yes.
get this information and update according to these changes.
Okay.
But here in RSTP they were changing, sorry, in STP they were sending TCN. After
Yes.
TCN, configuration BPDU was sending the changes information, right?
Yes.
And TCN was to inform that my friend something is changes.
Yes.
Okay. Now, so here there are 8 bit, okay, in the flags. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, and 8 bit is there. Okay,
Okay.
so total 8 bit information is there. So in 8 bit what they are sending, normally STP use TCN.
Okay.
Okay, TCN is number 7 bit. 65432 1 is not in use, and 0 was
Okay.
to TCAC, means yes, you sent topology
Acknowledge.
change notification and I received, that's it, I changed it. That's why
Mm.
there is no any kind of negotiation and something. But here in RSTP it is little bit different as compared to STPC. Suppose I have two switches. Okay, suppose I have two switches. Okay, let me take one. Okay, let me take one switch, just wait. Okay, so now if we are coming here, so STP we understood is very simple. If there is changes, it will send that notification, and after accepting, you will say that yes, I accepted it. Okay, but now here the flags, how the changes are there. Suppose if any information is traveling, okay, so this BPDU, see this is the BPDU, right? So switch,
Yes.
like in RSTP, I told you that both switches will generate BPDU, right? So
Yes.
same information you are generating and same information switch 1 and switch 2 both is generating. Okay, so suppose if these information is traveling, so how you will know that what I have to do, whether I will be root switch, okay, whether you will be root switch or whether you will be non-root, whether you will be DP, your port will be DP, RP, block, whatever will be there, everything will be
Yes.
depending on the this information. Okay,
Yes.
now so 7th bit is TCN and it is not in use, forget about this. Okay, okay, now number 6 bit is proposal. Proposal means whenever any switch, okay, suppose remember here they are calling it as a proposal, but it is it is BPDU message. See, when you on the switches, switch 1 and switch 2 is on, right? So by
Yes.
default, this switch is telling that I am root, and this switch is also telling I am root, right?
Yes.
And they will compare MAC addresses, breach ID, priority, then they will say, okay, no problem. Okay, now you are root, so your port is DP, I am non-root, so my port is
RP.
RP. So those things, they compare between them, right?
Yes.
Okay, so switch 1 is also sending the information to switch 2 to compare, and switch 2 is also sending some information to switch 1 to compare. So that the comparing message is known as
Proposal.
proposal. Very good. Now, okay, so once after proposal we decided, okay, you are root put and I'm non-root, fine. Okay, so proposal bit is used for what? Now tell me. Proposal bit is used for what?
Yeah. To compare
to, to compare
the
who will be
BPDU.
root and who will be non-root.
Yeah.
Okay,
Yes.
now so okay, root has been decided. After that, port roles will come, right?
Yes.
Okay, now when the root port is decided, okay, sorry, root is decided, so root port will come. So for root port, port roles, there are bit 5 and bit 4 is used. Okay, now understand.
Yeah.
If bit number 5 is on,
Okay.
okay, or, or bit number 4 is on, okay, if both is on, this is on means what? 1, right?
Okay.
1, then this port will become DP.
Okay.
See,
Yeah.
understand, if you will tell me, okay sir, repeat, I will repeat, because I know that in a first section you will not understand, because this is a little bit tricky. Okay, see here,
Yes.
normally there is 8
Yes.
bit. Okay, because see, in
Yes.
computer networks, every information is shared between
Start
the
from zero.
yeah, between the between the computers, between the routers, in bit form, right? Whether it will be
Yes.
16 bit, 32 bit. See, like IP is using 32 bit, right? Okay,
Yes.
MAC address is 48 bit, IPv6 is
Okay.
128 bit. So those bit is what? Because when
Yes.
computer wants to send any information to another computer, they use bit. So here also,
Yes.
STP and RSTP, they are sending some informations in the network, right? So they are sending those information in bit form.
Okay.
So they are using 8 bit, 0 1 2 3 4 5 6 7. So in all 8 bit, okay, what informations are there, and depending on those information, the port role, router role, states will is decided. So in TCN is not in
Yes.
use. Number 6 was proposal. Due to proposal, root switch 1 is root
Yeah.
now, right? Now,
Yes.
now if this be, if after proposal, right, proposal is sent in every 2 seconds, right?
Yes.
Okay, so switch 1 was sending proposal, okay, and this one was also sending proposal. Now when switch 2 came to know that, okay, root 1 is switch 1 is root, so okay, no problem, I will not send proposal. Okay,
Okay.
I will not send proposal for becoming root, right?
Good. Yes.
Now I will send other information, because now I'm sending BPDU, right? Okay, but
Yes.
now see, proposal was sent as a, see, this is bit number, okay, this is bit number,
Yes.
okay, but when
Uh-huh.
you are sending, so when you are sending, so when it is on, sorry, I have not written it, I forget to write it. Okay, now see, if I am sending TCN is off. If
Yes.
normally I will send one first on,
Okay.
so I will also send as a one. See here, switch 1 is
Okay.
also sending proposal as 1 bit on, and you are
Yes.
also sending proposal bit on, means both switches is fighting to become
Yeah.
root. Are you
Root
understanding?
base.
Yes.
Yes.
Now after comparing, okay, like you compared
Yes.
that, okay, who will become root. So switch 2 came to know that, okay, due to proposal bit, I tried to
Yes.
become root, but due to my lower priority I am not root. Okay,
Yes.
but my bpdu is always been sending.
Yes.
Okay, so now switch 1 will send proposal bit on always, because I am root, my proposal bit will be always on, right? Because maybe in the network
Yes.
there will be some other switches also.
Yes.
Okay, now, but switch 2 will not send proposal bit on towards switch 1, but are you understanding? Towards
Because
switch.
he's already the root.
Yes, because switch 2 know now that switch 1 is root. Okay, and
Yes.
switch has added about the priority of root and everything in his STP, right? Spanning
Yes.
tree. Okay, now they will fight for port roles. Okay, so we have
Okay.
two type of port roles, or three type of port roles, you can say, right?
Yes.
Yes, we have three type of port roles: DP, RP,
Yes.
and alternate, right?
Yes.
Okay, now come here. Now number bit 5, if bit 5 is 1 and bit 4 is 1, right? Okay, if bit,
Yes.
so who is sending that? Yes, if I am root, okay, I am root, so my all port
Yes.
will be what? If I am
Designated.
root, my all port will be
Designated port.
designated. Yes, very good. So this port 5 and 4 is used for port selection. No, port selection.
Okay.
So if 5 is also
Okay.
on and 4 is also on, right? Okay,
Yes.
so switch 1 is advertising that, my friend, my E0 slash 1, okay, E0 slash 1, because see, switch 2 is receiving this BPDU from E0 slash 1, right?
Yes.
Okay, so bit is on, 5 is also on, and 4 is also on, means this port is DP.
Yeah.
This port is DP. Okay, so if this port is DP, means my port is
RP.
RP. I cannot put my port as a DP here. I will, because the bit what I am receiving as a on. So whenever the message
On.
will be
Yes.
advertised, means the port is DP. Now if,
Okay.
now switch 2 will advertise what? Switch 2 will say that same, because I am also advertising this same message, right? So on place of proposal, now switch 2 will
Yes.
put what? 1 or 0? Switch 2,
Switch to 0.
0. Very good. On port role,
Yes.
is written
Yes.
here. Okay, so port role,
Yes.
on 5 what he will put? 1, and on 4 what he will put? 0.
0.
5 1 and 4
Yes.
0.
Yes.
Okay, so the port role is, for him is RP.
0.
So
Yes.
yes, so switch 1 will know that, okay, the port which is connecting to me, okay, uh, my neighbor port, which is E0
Yes.
by 1, that is RP. Okay, so I will be
Yes.
sending information towards him regarding data and some other things. Okay,
Okay.
now
Yes.
if, maybe if this port, maybe you want to block it, right? For example, so
Yes.
the bit number 5 is 0 and bit number 1 is on, sorry, bit
Yes.
number 5 is 0 and bit number 4 will be on, then port will be alternate or block, backup. Okay, now
Yes.
port bit number 3 information. In this bit number 3, they will
Okay.
go for learning. Okay,
Learning.
yes, means if bit number 3
Those
is
guys are
on,
listening.
means, yeah, bit number 3 is on, means my learning process is running. And if bit number 3 is
Yes.
off, 0, means my learning process has completed.
That's the problem.
No, it's completed.
Okay. Completed.
Okay, yes. If 2 bit number 0 is
Okay.
2 is 1, means my forwarding means I'm in forwarding state, means I'm about to in forwarding state. Okay, see here, if my bit
Yes,
number
it's
1,
running.
yeah, means I am in forwarding state, but if it is 0 means I'm not in forwarding
Okay.
state. Okay, are you understanding?
Okay.
0 means no, 1 means on.
Yes, I see.
Yes, and 1
Yes.
last number is agreement. Okay, agreement
Yes.
means, see, agreement is little bit different as compare. Agreement means, see, now switch 1 and switch 2, they see they those communication what we are talking, these learning proposal, state defining, port defining, it is in nanosecond quick. Okay, but
Yeah, it's
I'm
something
yeah,
that's
I'm
running fast.
explaining, so it is taking time, it's not that. Okay, so now after this decision, when it will come to bit number 1, right, bit number 1 the final, so
Yes.
switch 2 will send agreement to switch 1 to root. Okay, that
Okay.
as
It's
we
like everything is
decided,
separate for you.
yeah, as we decided everything. Okay, that you are DP, I am
Yeah.
RP, you are root, I am non root. Okay, so I agreed on the proposal what you have sent to me. Okay, so when
Yes.
agreement is sent via switch 2 and received via switch 1,
Switch one.
yes. Okay, when agreement is sent and received, then the both port DP and RP of switch 1 and switch 2 will be moved to forwarding state.
Forward.
Yes, till then, or till before. Okay, till before whatever process is running. Okay, at that time the port will be in discarding state.
Discarding.
Yes, learning and everything is going on, no problem. But once you will send and receive the agreement, you sent and I received, so automatically port will be moved to forwarding. Okay,
Yes.
but which port will be moved to forwarding, the question. So, suppose you are connected to, maybe I am here, right, I have some other
Okay.
switches is also connected here, right. Okay, okay,
Okay.
now this will be DP, right, and this will be RP,
Okay.
right.
Yes.
Okay, so when this port will send, okay, see, understand here, first understand this theory, then you will understand. Whenever RSTP, whenever switch received superior BPDU, it performed
Yeah.
two tasks. Okay, see, switch
Yes.
received superior BPDU. So who received superior BPDU, switch 1 or switch 2?
Switch two.
Switch 2. So after receiving superior BPDU, synchronization, two tasks here, two task is running.
Yes.
So one is synchronization and second one is agreement. So
Agreement. Yes.
synchronization is saying that except the root port, except the root port, understand this one, except the root port
Yes.
where it has received, where
Superior.
superior BPDU has been received. Okay,
Yes.
okay, from the root switch, means except this port, maybe I have 10 5 ports
Yes.
like that. Okay, non-root switch will put all the ports in
Discarding. State.
discarding state. Means he, see, why non-root switch is putting these all ports in discarding state, is saying that please, even my root port is not up, wait, just wait for few seconds. When my root port will
Yeah.
up, then I will think about your, what your port will be, whether you will be block, whether you will be forwarding, alternate, backup. Let me first decide myself first. Okay,
Okay.
okay, then when, now agreement is sent. Synchronization means when I decided that yes, I am non-root. Okay, then once I
Yes.
decided that I am non-root, and why I decided that I am non-root, because I have received
Superior BPD.
superior BPDU. So once I will receive superior BPDU, so I received superior BPDU here or here,
Via RP.
RP. So except RP, I will put all the port in this discarding state and I will keep
Discarding.
them in hold. Okay,
Yes.
and I will send agreement and negotiate with DP, okay, with the root port. So agreement, the port which is root port of switch of non-root switch, it will
Yes.
send agreement to root switch.
Root.
So whoever send or receive the agreement on the same
Link.
RSTP link, okay, link, RSTP will immediately put those ports into forwarding state. Now,
State.
so on this switch, on this link, our switch 2 is sending and switch 1 is receiving. But on which link? E0 by 1 link, right?
Yes.
So
Yes.
automatically this port will be in
Forwarded.
forwarding state. Okay, now understand this one. RSTP takes 30 seconds to bring the port into forwarding state. But which port? The port which is in
The
discarding
remaining.
state, okay?
Yes.
But the port, but these ports, see, but here this rule is not working for RP. This rule what we are talking here, 30 seconds, will not work
Yes.
for RP because RP is using agreement. So here is saying that
Yes.
whoever will
Except.
receive superior BPDU, so
Yeah.
it is in discarding. So for them it is 30
Yeah.
seconds, but for me it is quick because,
Yes.
yeah, due to algorithm which is running. Note,
Yeah.
agreement will be sent only from root port
Root port.
where it has received the superior BPDU. So maybe I have 4 port, 5 port here. So the switch 2 has received superior on root port E0 by 1. So your switch 2 will always
Yes.
send agreement via this one. And agreement is
The root
sent
port
only
is.
one time, not multiple times. Okay.
Okay.
So once the agreement is sent, so while sending agreement bit will be on, okay, and once the agreement is sent, so now it's okay, done.
Okay.
Okay, now, so here we have already discussed this one, RTP port, state port roles. Now, example of few problems in RSTP switching networks. Okay,
Yes.
okay, so now understand this problem. Now problem is that what I told you, when the switch 2 and switch 1 is sending proposal has decided that you are root switch and I am non-root. Okay, after proposal we decided our port roles, right, DPRP. Okay, after that learning has learning took 2 seconds and then forwarding took uh, 2 seconds, you can say 2 seconds only, then it moved to forwarding.
Yes.
So when my port tried to move to forwarding, okay, so before moving into forwarding it sent some agreement
Yes.
towards root, and once I sent agreement and switch one received, so automatically this port is on and it in forwarding state.
Yes.
Okay, but if now same here but with PC. Okay, okay, now
Okay.
here's DP. Okay, so here I should explain you something. Okay, now for example, first understand this lab, then I will explain you this lab. Okay,
Okay.
so proposal sent, decided root switch, non-root. Okay,
Yes.
now see why I am explaining here, because those conversions between switches in RSTP is in nanoseconds. Okay, so
Yes.
I cannot show you those port. Okay, in STP I was showing you
Yeah.
listening, learning,
Super
but
set.
yeah, but here
Yes.
if I will go to show you, immediately the port will
Yes.
be in forwarding.
It was. It
Yes,
has already happened.
yes. So here I am explaining you that root port is decided due to proposal, root switch port is decided by the our port states, and then agreement sent, and when agreement sent, So this port is forwarding and this port is forwarding. Okay, so till then this port will be what I told you, except the port who is receiving and sending agreement, except these
Yeah.
ports, all port will be in,
Discarding.
whether it is root switch port or whether it is non-root port.
Okay.
Okay, so now if this PC wants to communicate to this PC, so the communication is
Off.
down and it has to wait
Yes.
for
30 seconds.
30 seconds. Same problem. Okay, so we have to enable port fast. Okay,
Okay.
that's why we have to enable port fast, because if this port will go into discarding, so it will not come directly to forwarding, because after discarding it will go for learning and then it will go for forwarding.
Yes.
Okay, so that's why these port take times. Okay, and when it take time, so that's why we enable port fast. Okay, but uplink fast and backbone fast is not required, because it is faster, because that is the communication between switch to switch. So switch to switch communication is immediate, that's why port fast and sorry, uplink fast and backbone fast is not required. Now see what was the problem. See here, if this link, okay, if this, suppose this link is down, right?
Down. Yes.
Yeah, due to some kind of like link problem or something like that, right? So okay, now tell me,
Yes.
this switch will say what? I am root. Okay, and this switch will say what?
Yes.
I am root, right?
Yes.
Okay, now if this link is down, so do any agreement is moving around?
Nothing.
Proposal agreement here,
Nothing.
here,
Yes. Nothing.
nothing, right? No one is
Yes.
generating. See, I am generating, but you are, maybe I am generating here, but you are not understanding my
Yes.
BPDU, right?
Yes.
I am generating, but I am not receiving any kind of.
Yes.
So what you have understood, till agreement is not moving between switches, till agreement is not moving between switches, all port will be in what?
Discarding.
Discarding state. So this port is also down, so this port is also down, so whole network is down. Okay, that's why when port fast is enabled, okay, so at least your communication will move. Okay,
Okay.
or maybe your this port is down. Okay, but maybe this computer is connected to switch is connected to router, so at least this traffic is moving. I know, I can understand this traffic is blocked, but due to port fast your computer is communicating to router and you are communicating to internet, like that. Okay,
Yes.
now show STP time issue and problems using the below lab by disabling and enabling the ports on switch 2. Okay, no problem, let me try. Okay, let's see the lab.
Okay.
Rstp. Okay, so here we are, see, you can see the lab here, it's showing that so STP time issue and problem using the below lab. Okay, so here we are talking about STP time problems, and then now I will show you the now show RSTP faster port conversion Also show the problems using the end devices and port status. Okay, so this both lab we can check here. So now we are checking first RSTP problem, sorry, STP
Okay.
problems. So maybe this is PC. So let me put one IP address, IP 192.168.10.10/24. PC1 is 10.10. IP 192.168.10.20/24. Save, save. Now if I am coming to switch 1, so spanning tree. Okay, peer STP E0/1. Okay, it is neighbor. Peer means
Switch.
no. Peer
Switch.
means
Switch.
neighbor.
Yes.
Okay, neighbor STP is running on this interface.
Yes.
Okay, so I can run here. So spanning tree summary. It is running rapid PVST. Okay, so my God, let's can we change it?
Okay.
Conf t spanning tree mode MST PVST PVST PVST. Let's make it PVST. Okay, come to switch. So we are making it as a normal STP. Okay,
Okay.
then because spanning tree PVST, then if we are coming here, so spanning tree, fine, listening learning process started. Can you see here?
Yes. Yeah, I can
Listening
see.
learning. Okay, so no problem. Okay, now if we are coming here, so spanning tree summary, it is now your PVST mode. Fine.
Yes.
Now if PC1, I think listening learning is completed. Okay, forwarding state. Fine. PC1 is trying to communicate ping 192.168.10.20 minus C, like that. So they are communicating. But what happens
Yes.
if conf t interface E0/1 shut, no shut?
Yes.
Port is up. Now see, port is up, but still you have to wait till
30.
30 seconds, because see, if you check here, switch 2, so spanning tree E0/1 is still in listening process.
Listening.
Yes, then it will go for learning process. Okay, then it will go for forwarding. Till then, see how many packet is dropped. Now you can check it. So I think 30 packets will drop, right? Then the
Yes. Yes.
communication started. Okay, so this was the problem in
Yes.
your normal STP,
Yes.
right? PVST or whatever. Okay, now, but if see, RSTP came. Why RSTP came? RSTP came to resolve the problem of slower time conversion, right?
Yes.
Okay, so if we are coming to switch 1, switch 1 conf t spanning tree mode
RSTP.
RSTP PVST, right? Because it's a
Yes.
Cisco device, rapid spanning tree. Okay, let's come here to this switch 2 conf t. Okay, so spanning tree summary. Fine, now it is RSTP, right? Okay, now Okay, now can you see some message here?
Okay.
See, blocking,
Understand.
if you'll see total port number, so total port number on the switch is total is 16 port. So except one
Yes.
port, it has
Yes.
kept, except one port, it has kept in,
In discarding.
yeah, discarding is blocking. Okay,
Yes.
and after conversions that, okay, you become root and I become non-root, root port designated, when they have decided, then it is now,
Yes.
there is
Zero.
no any blocking port.
Yeah.
Okay, but can you see here
Yeah. 15 learning.
learning, and now if you'll check here, now learning has completed. Did you understood
Yes.
something?
Every, yeah, every
Okay,
port is.
now if you will see something, control C. Okay, so let me come to switch 1 and let me make that port into trunk. Maybe conf t interface E0/1 switch port mode, and not mode, switch port trunk, switch port mode dynamic desirable. Do we have something dynamic desirable? Okay, so they will negotiate and it will become trunk, right? So
Okay.
interface trunk, fine. Encapsulation is there, okay, fine. Okay, so switch, okay, fine. Port is, now see, can you see here, now all port came into forwarding state. But if you see some messages in the beginning, right,
Yes.
only one port was forwarding. Remember the theory?
Yes.
Okay,
Yes. Yeah. I remember.
all port in disable state, right?
Yes.
One port is, okay, in forwarding,
One.
and now they move to learning for 15 state, 15. Okay, and then learning is completed. Okay, see,
Yes.
because you
The
can see
no
here there is
complete.
no listening block
Yes.
is there, but the packet is not moving to listening. See, after blocking directly they are
Yes.
moving to
Learning.
learning and they are moving to forwarding. Okay, but you can see here one port is always in forwarding. Are you
Yes.
understanding? One port, which
Yes.
port? The port which is sending agreement.
Yes.
Okay, so now if you see what we were talking here, okay, trunk is okay. Now what I am doing, I am coming here PC1. See, conversion is fast, but if I am coming here,
Yes.
okay, now I came to switch 2 again.
Okay.
Conf t interface E0/1 shut, no shut. Okay, so spanning tree, see here. So spanning tree summary. Okay, see here, blocking, can you see here, blocking, blocking,
Yes.
blocking, blocking, and you can see here no communication, can you see?
Yes. There's
Okay,
no communication.
blocking, learning. Okay, learning, and if you'll see, still blocking, see here, still port is blocked.
Yes.
Learning, 15 seconds, 15. Okay, now came into forwarding, then the communication will start.
So
So
30 seconds
yes,
completed.
yes, means root and non-root they are communicating. Are you
Yes.
understanding? Root and non-root,
Yes.
they are communicating, but the problem is still there. So if I'm coming here to switch 1, okay, let's run some kind of debugging. Debug spanning tree events.
Okay.
Now let's come to switch 2 as well to run this one. Okay, and I'll come here, conf t interface E0/1. Okay, shut, no shut for same process. Okay, and just wait
Yes.
something. Can you see something?
Proposal.
Proposal.
Yes.
Now you will wait for agreement also. Proposal
Okay.
is communicating. Still, and still if the proposal is going on, still there is block, right? Okay,
Yes.
still blocking is going on. Proposal is going on. Transmitting proposal. Agreement, we will have to wait for agreement. See,
Yes.
okay, when agreement will come, FD while, I'll explain you about this. Okay, FD while expired.
Okay.
Okay, okay, and now there was some kind of proposal agreement. Maybe we can try events or some other debug spanning tree all. Okay, let's try this one. My god,
Okay.
if this all will, you will not understand. Wait. Yes, in 2 seconds you will not understand. Some agreement should be there. I'm just debug spanning tree bpdu. Okay, bpdu
Yes.
question mark bpdu transmit or receive. So maybe agreement I am sending, so I can write transmit. Okay, just wait, transmit. So in 2 seconds I am sending bpdu. Fine. So what I will do, I'll come to conft interface e0 by 1 shut means there will be no bpdu sending. So bpdu I am sending only via switch 2 is sending via okay, other ports except e0 by 1. Okay,
Yes. Yes.
yeah, other port. Okay, fine, no problem. And you remember, you know that, okay, you can stop sending bpdu from these interfaces also, right?
Okay.
Okay, you can stop sending bpdu. I'll show you. Okay, then I'll come here, no shut. Till then you can see communication is bad. Who is sending agreement? Proposal transmitting. See, fd while is a one kind of timer. Okay, okay, I'll
Yes.
explain about this timer. It is there in the slide also. No shut. Now just wait for any kind of agreement. Ethernet port is up. Agreement is received via this. Switch 1, let's see
Or
here.
maybe try
Transmit.
with just PPT.
Transmitting proposal. Communication started or what? Timeout. Did I wrote what? Shutdown or no shutdown?
PPT. Shut
Okay.
down.
Interface E0/1 shut and then no shut. Fine.
Yes.
Okay. Just wait for sending proposal. Transmitting proposal. Okay. Just wait. Maybe here we can get some kind of receiving agreement or what. See, when port was down, right? So Rstp
Yeah.
has generated TC. Okay, topology change,
Yes.
not topology change notification.
Yeah.
Transmitting,
Yes.
transmitting, transmitting. Where is the agreement?
You
Maybe
can even maybe try with this one BPDU simple.
you all. Maybe agreement is there, but maybe I'm not running perfect debug spanning tree.
Perfect.
Okay, but see what I want to tell you here, that till the
Yes.
agreement is shared between these, okay, the port will be in discarding state. So for your
Yes.
30 seconds or maybe 50
Okay.
seconds we have to check. Okay, and your pc1
Okay.
and pc2 won't be able to communicate due to this problem.
Yeah.
Okay,
Okay.
so what we have to do, we have to come to switch 1.
Okay.
Transmitting proposal, generating tc, no agreement receiving, only transmitting. Okay, okay, so no problem. There's conf t. Then let me stop the communication first. see communication is stopped now. Okay, no problem. Let's start the communication. So what I will do here, I will type here spanning tree port fast default. So whenever I will run port fast default, right? Okay,
Okay.
see here port fast default is not working. So can you see here edge is working, remember? So
Yeah, edge is there.
edge means enable port fast on access port. Did you
All
understood?
devices. Yeah.
Yes. Okay, edge, sorry, edge default. Okay, edge default means enable port fast on access ports. Okay, so
Okay.
I'll come here, copy, and I'll come to my switch to conf t. Okay, and automatically spanning tree port fast question mark. My god, this switch is a different. Okay, this is a different version. Can you see in
Okay.
two version switches we are getting here? See, let's check here. So version here we are using 15.1 and switch 2 I am using, I
One.
think so, spanning tree.
So version.
Okay, sorry.
So
So
version.
version here I am using 15.2. Okay, so here you
Okay.
can see command is different and here command is different, right?
Yes.
But we have enabled port fast. See, spanning tree port fast edge default in the newer version, and in the older version spanning tree port fast default. So whenever you will run this command, so it will be enabled on the access port,
Yes.
access the ports. And you also know that access port we use for end devices, right? And here we have
Yes.
already enabled trunk. Okay,
Yes.
okay. So now if I am coming here, see they are communicating. If I am coming on switch 2 and conf t, before that can we run debug spanning tree events. Okay, and now I'll come here conf t. Okay, interface e0/1 shut and uh, sorry, conf t
That's it.
interface e0/1 no shut. Okay, and immediately I will type here so spanning tree summary. Can you see here immediately my ports came to forwarding, right?
Yeah. Forward.
And now see received superior bpdu fast, it's okay. And now you see the communication is okay. We'll start the communication, but you can see here ports are up.
Yes.
Okay, still okay, proposal is going on, but these ports should okay. No problem, we can check their status. So spanning tree, see listening learning is going between which one,
Yes.
between e0/1.
Yes.
You can
Last
see
one.
here, yes, e0/1. But you can see here the port which is connecting e0/0, e0/0 is in
Forward.
forwarding state. Even on switch 2, so spanning tree, see listening learning will go, but this will be in the designated. I can show you again, interface
Yes.
e0/1 shut, right, and no shut, right.
Yes.
And now you can see here spanning tree, see e0/0 designated,
Yeah.
see,
Forward.
yeah, e0/1
Yes.
is not there. Okay,
Yes.
received superior bpdu transmitting proposal, see, okay. And this route will also
Yes.
immediately come in forwarding. Why this route will come
Yes.
immediately in forwarding? Because it is sending agreement. So
Yes.
the port which will send agreement and receive agreement, it will come immediately up. So this port will also come up immediately, and this port will also come immediately, means your entire network is up.
So yeah, the problem is solved.
Problem is solved, right? Okay,
Yes.
so we have seen this one, why Rstp do not need uplink fast and backbone fast. Now see, this lab is for you, okay, but now see
Yes.
what will happen now. But I can explain you here, but you do it at your own. See,
Okay.
Suppose this,
Okay.
on this link I have enabled port fast, right?
Yes.
And on this link I have enabled port fast on switch 1 and switch 2, right?
Yes.
And remember about uplink fast. Okay, for switch 3, this link is uplink, this link is uplink, right?
Yes.
Okay, so if this link is down,
Yes.
okay, and this link was blocked, so immediate, normally it was taking 20-second wait, okay, and then
Yes.
15 say 15 like that, right? In
Yes.
uplink
Yes.
fast. Okay, now what happened in Rstp? See why
Okay.
we don't need uplink fast. Suppose if this link is down, right?
Yes.
Okay, this switch will try to find my root switch.
Okay.
Okay, because see, of course this port will be in, for few seconds it will be in blocking, right?
Yes.
Okay, if this physically it is down, maybe cable is problem, but this port was not down, it was blocked due to some STP process, right? But we
Yes.
are now, there is no block, just remove this one. Okay,
Okay.
or maybe you can say block, because a block option is also there in Rstp as well, right? Okay, so it was
Yes.
block, suppose for it is, maybe it is block, you can say it is block, and this link goes down. So immediately it will try to send some BPDU.
Okay.
When it will try to send BPDU, so proposal bit, so it will say, okay, now you are root, I am non-root, no problem. So I received some proposal information from root on this one, because see, when the port is blocked, this port is blocked, so switch 3 will not send BPDU, but switch 3 will receive
Yes.
BPDU. So when this one is
Yeah.
receiving proposal, something like that, so when you are
Yes.
receiving, you will send proposal, sorry, okay, you will not send
Agree.
proposal because you are non-root, right?
Yes.
Okay, so when you are receiving some kind of information proposal, so you will say that, okay, let me send you agreement because there is no other port. Okay,
Yes.
okay, and who will send and receive proposal? The port who is receiving BPDU from root. So this port
Yes.
is not
Yes.
receiving BPDU, okay, but this port is receiving BPDU, so you will say yes, yes, okay, let me reply with agreement. So when you will send agreement, immediately it will come up.
Yes.
That's why there is no uplink fast and,
Uplink.
yeah, backbone fast required here. Okay,
Okay.
okay, so see, Rstp is only conceptual, okay, that but with this lab we have understood something, right?
Yes. Yes.
Yeah, the benefit of Rstp according to
Rest.
time
Yeah.
and according to port fast, right?
Okay.
Okay, but what I am recommending you, I think the lab is with you, right? You have your GNS, something like that. Okay, so whenever you have time, you
Yes.
try this one. Okay,
Okay.
if you try and see whether the uplink fast and backbone fast is working same like STP, or RSTP is immediately putting, bringing these ports up, or do we need to
Okay.
enable RSTP or some, sorry, uplink fast and backbone fast? Because if you'll see here,
Oh.
okay, let me show you. So spanning tree summary, okay, see here, port fast is enabled, okay,
Yeah.
and uplink fast and backbone fast is disabled, okay, but yeah, but if you'll come and check here, so spanning tree is not important and required, okay,
Yes.
yeah, bridge pvst, okay, but it is not required, okay,
Yes.
yeah, port fast and uplink fast is not required, okay, okay.
Coded conversions,
If
of
you want,
course.
maybe, yeah, if you want, I can show you, maybe we can have some labs, older labs, right?
Okay.
Let's see, let me show you instead of waiting. Proposal, uplink fast, backbone, uplink fast, RSTP, backbone fast. Okay, fine, no problem. Okay, so let's come here. Okay, enable all the switches. So after enabling, what we can do, let's take a console of all the devices. So PC1 we will put IP address. IP 192.168.10.1/24. Save it. PC2 IP 192.168.10.2/24 and save it. Now I am coming to switch 1. Simply I'll come here, conft, what happened, conft spanning tree mode Rstp. What happened, my system is slow. So Rstp mode, yes, just a second. Okay, so switch 1 enable PVST, switch 2 enable PVST, switch 3 enable PVST, and what we can do, we can run some kind of port fast as well. So come here, conft spanning tree port fast default or edge. Okay, edge default. Okay, and what we can do, we have to change some interface, right? So switch 1 interface E0/0. Okay, interface range E0/0 and 1, right?
Yes.
Yeah, switch port mode, sorry, switch port mode dynamic desirable, dynamic desirable. Let's them negotiate. Okay, so switch 1 is completed. Now switch
Okay.
2. So I'll come here, interface range E0/0/ no, not 0, range E0/0 comma E0/2, right? Switch port, switch
Yes.
2, switch port mode dynamic,
Yes.
switch port mode dynamic. Why is not coming? Switch port mode trunk. Fine. E0/0 is auto. Okay, so interface trunk. Yes, my both E0 and E2 is trunk, no problem. Switch 3. So interface trunk. Okay, my E1 and E2 switch. Okay, fine. Every port is trunk. Okay, except 0303. Okay, on switch 1 and switch 2, right? Okay,
Yes.
fine, no problem. So let's enable. We have enabled switch 2. I have enabled this one. Okay, no problem. Conf t spanning tree port fast edge port fast default. Okay, fine. Switch 2 and switch 1 is conf t spanning tree port fast edge default. Okay.
Before, yes.
Okay, and now if I'm coming on PC, they are communicating, right? Okay, if
Yes.
I'm coming on switch 3, okay, and so spanning tree, okay, you will see that uh, E0 by 2, okay,
Block.
is block. E0 by 2 is block as per our scenario, right? You can see this
Yes.
scenario, right?
Yes, I
Okay,
can
is
see.
block. Now remember we saw that, okay, if this port is down, which one?
Yes.
E0 by 1, right? So how
Yes.
much
Easy.
this E0 by 2 is taking time, right? So let's check
Yes.
conf t interface E0 slash 1 is short,
Shut. Yes.
right? Short. Now see here, so spanning tree E0 by 2 immediately
Forward.
forwarding, no need to wait. And you can see here communication. Do you think that communication is stopped for a second also?
No. No.
So there is no need of uplink fast and backbone fast.
Yes.
Okay, now no
Everything
problem.
first.
Let's come to switch 2, switch 3, conf t, okay, interface E0 slash 1, no shut. Okay, let's bring the port up and check the status again. E0 by 2 is root, no problem. The port status, okay. See here, remember those
Yes.
negotiation is running, remember, except this E0 by 1, except E0 by 1, all the port will be in what?
Block.
Blocking state.
Static.
Yes. Okay, but see, but this they are communicating, no problem for them.
Yes.
Okay, now what I'm saying, we want to verify about backbone fast, uplink fast we have verified, right? So now see,
Yes.
E0 by 1 is root and E0 by 2 is
Block.
non-root. Sorry,
Yes.
this one block one, right?
Yes.
Okay, so we can check how we can check for uplink fast. If this link is down,
Yes. And then we'll check on
no,
S3.
maybe if we add one more switch, then we can check uplink fast, right? Backbone
Okay.
fast. Are you understanding? For
Okay. What
backbone,
about this one? If the link between 1 and 2 is down, and then we'll check from the switch tree.
no, but switch 3 is communicating to root from this link, directly from this link.
Yes. Okay.
Okay, no problem. Yes, here we can check this one. 3 by 3, 3 by 2,
Okay.
start and take console and enable Rstp first, right? Because
Yes.
if you not enable, maybe if the switch is older version, spanning tree mode Rstp rpvst, spanning tree rapid, okay, rapid pvst, fine. Okay, so spanning tree blocking, only one is in forwarding. Can you see here, all is in blocking state.
Yes.
Once the negotiation will complete, then they will go for learning, learning.
Still on
Yes, forwarding, fine.
forward.
Okay, E3 by 3, we have to check E3 by 3. So instead of E3 by 3, let me make it E0 by 0, because delete, because we have to scroll to get the information. So here I can use E0 by 1, here E0 by 0, E0 by 1 to E0 by 0, like, okay, maybe E0 by 0, fine. Okay, just wait for again, because again the process will be going on, right?
Yes.
see, now port is okay, fine, everything is okay. So my this, see, you can see here on switch 4 you have two link, E0 by 0 which is forwarding towards root, and E0 by 1 which is block.
Yes.
Okay, now what will happen,
Okay.
suppose if this link is down, right, because I am going to route via this link, right? Okay, via this link.
Okay.
Okay, so let's make this two link as a trunk first. Okay, so
Okay.
conf t interface
Interface.
range
Yeah.
E0
Is
slash
0 by
0 slash
0.
1 switch port mode dynamic.
0.
Okay, trunk. Okay, maybe they are trunk, so interface trunk. Okay, they are trunk. Okay, so
Okay.
switch 4, my god, how many interfaces trunk switch 4? Okay, no problem. Okay, so now I'm checking here, so spanning tree. Okay, so it's okay. So for that my route E0 by 0 means I'm reachable from this link, right? So for this link,
Yes.
my this link is what? This is my uplink, uplink.
Yes.
Okay, this is also my uplink for switch 4,
Yes.
but this is backbone and this is also backbone, right?
Yes.
So let's write backbone, backbone.
Okay.
Okay, so if E0 by 0 is down, let's see how much time it is taking, right?
Okay.
So switch 2 interface E0 by 0 is shut. Switch 4. Switch 2 E0 by 0 is shut. Now if come to switch 4, so a spanning tree. See, E0 by 1 in immediately forward.
Forward.
Or
Yes.
earlier it was block.
Block.
So immediately it came to forwarding state. Other is in blocking.
Okay.
So that's why
Only
uplink fast and backbone fast is not required in Rstp.
Rstp. Yes.
Yes. Okay. Now one thing I forget to explain you. As we have multiple types of port, okay,
Yes.
so we have some kind of DP, RP, alternate and backup, right? So DP
Yes.
is DP, RP is okay, alternate is for what and backup is for what? Maybe I think I have written
Yes.
somewhere, or maybe I forget to write it. No problem, I can come to. Because see, in normal our STP we know that, okay, root is to reach root, DP is to communicate other non-root, right? And block is to
Yes.
communicate, sorry, block is to wait because to stop loops, right? But here in
Yes.
Rstp we have some kind of redundancy, we have
Backup.
block as well as we have backup, right? So why we have backup? So
Yes.
here I have already pvst Rstp. Okay, okay, see this one. Okay,
Yes.
so in here in STP we have DP. Can you see here DP, RP, alternate, right?
Yes.
So alternate is for what?
Yes.
Alternate is a backup of your RP and DP, right?
Yes.
Alternate means, see, if I have here alternate, this is block, right? So if this block will come up, right?
Yes.
Okay, so it will become what? RP or DP? It will become anything.
Yes.
Maybe if, see, if I have DP here, suppose this is my DP connecting to other, okay, right now this is
Okay.
what, this is DP. If you will come to switch 3, this is DP, right? This one,
Yes.
this is DP,
Yes. DP and the
right?
other one is
Yes.
prop.
But maybe if this link will go down, right? For example, so this block will either will become RP or either it will become DP.
DP. Yes.
If any link will go down, so this block will take over of that link, right?
Yes.
Okay, and here in Rstp, if DP is okay, RP is okay, see, alternate, if alternate is down, so alternate will only become RP, okay,
Yes.
and backup will become to DP.
RP.
That's why in Rstp we do not need uplink fast and backbone fast. Why? You remember about EIGRP? EIGRP always keep one backup link, that whenever any link will go down, I will not
Yes.
recalculate the path. Okay, immediately I have backup, I will take that backup link and I will reach to the destination. So same
Yes.
Rstp is also following, saying that okay, no problem, let's calculate backup
Yes.
path. If any link will go down, immediately I will take that backup path and I will reach to root, instead of reconversing and negotiating and talking with the other switches for the best path.
Okay.
Okay, so I think we are done with Rstp. Okay, see, STP, if you know STP very well, you will know Rstp.
Let's see.
Okay, you will know PVST. Okay, and when you know these
Okay.
things, after that we have this lesson which is known as MST.
Yes.
Okay, MSTP, multi-spanning
Yes.
tree. Okay,
Yes.
so when you know those things, you will complete easily these things.
Okay.
Okay, okay, so we will work on
Multi-planetary.
this tomorrow. Okay.
Okay.
Okay then.